can start off with that. Where's my...
Okay, can you see my screen?
Yes. Yeah.
All right. So yeah, we were given a task to make a case study to, I guess, do this, but I got this notification, so I don't think it's...
No. That means you that means we cannot use case study to vary the fit inlet location. But what you could do now, how many stages now? 9 stages, yeah.
Yeah.
And then it is on the stage number 3. And then can you then show the profile, the concentration profile of the column?
I still go.
Yeah, I also need to see how it performance, maybe a performance, and then column profiles, yes. And then plots. You can see also the plots.
Temperature, okay.
Composite. Yeah, you can show the temperature as well, and then you can also show both. And then you can show the composition. And then you can have then yeah, exactly. So we can see now. So we can see when we see the temperature profile, it's changing very nicely, right? So we don't have any locations of the trace where the temperature is constant, means there is no separation. So in these 9 stages, we see that each stage there is separation process going on, yeah, indicated by the change in the temperature. And you can see when you say that the fit temperature, the fit location at stage 3, and then we see a jump from stage 2 temperature to stage 3 temperature. Let's see. Composition, stage 3 is about 40%, 50% DME, water, and then about 10% of water, of methanol. If case study cannot be done, I think you could do a kind of like a little bit manual sensitivity analysis. So you can I don't know if you can do they have here case studies, no scriptures, no data. Does it have the if in the palette of HYSYS, does it have the like a calculator or something?
No, the data sheet.
Data sheet.
Nope.
Oh, can I open data sheet? What happens? What is that data sheet? No.
No.
No. No, it's different.
Calculator.
No, in the palette.
Oh, palette.
Yeah, that one. That one next to that range, in between range. Spreadsheet. Yeah. Maybe you can put it on the
Right.
Okay, double click on that. What's in it? How do I? Okay, and then go to that spreadsheet. The tab on the top, spreadsheet. We have the connections, parameters, formulas, and spreadsheet.
Okay.
That one. So I think here, what you could do is that you can make because you can use this as your like a Excel within Aspen. So what I think you can do is that you just vary manually the stage location, and then so that means in column A, for example, you can say stage number 3, maybe stage number 2, 3, 4, and 5 maybe, and then column B is then the reboiler duty, and in column C is then the condenser duty, and then you can see. We will do this manually because case study cannot do so, right? So and then and it should be okay.
Okay.
And then now stage 3, stage 3, stage 2, you can start with stage 2, 2, 3, 4, 5, maybe up to you. Yeah.
Right.
Okay, now stage 3, what is then the reboiler duty for the current situation? I can move it aside and then in the I think in the performance or design and the monitors, I think that one condenser reboiler. Yeah, that duty. Copy, paste. Can you copy paste? Yeah. And then now you change it to stage. Exactly. Stage 2. Run. You have to click on. And then copy condenser stage 2. Very quick, yeah. So
Right. That's fine. All right, Kenneth.
It's fine. It's it's just the pressure is not really okay, but in terms of mass balance, it's fine. But it's just we cannot use this for if you want to do like a dynamic simulation, you cannot start with this feed stage unless if you increase the feed pressure.
There's not much difference in this value.
Okay, and then I don't know how to do plot. I don't know how to do plots, but a second. What is on the parameters and check parameter tab? No formulas, no. Let's see how to do plot.
Oh, there it is.
What is that? Condenser duty.
Or is it connected?
No, it's not connected. It's just because you copy paste. They know that. For example, yeah, if you go back, where's that thingy?
Yes.
Because we copy paste manually, so it sees that C2 is then that number, and then C3 and so forth. So it's just like the location. If you go send to step chart, no case study, no step chart. What's in the step chart right now? Nothing. Nothing yet. Nothing yet.
Let's see. Data logo.
Data longer. Show it.
Display.
Try.
There is nothing.
No, nothing. Yeah, no. This data logger is more like this is more like if you do like dynamic simulation. It is there, but not okay. So let's just go back to that spreadsheet and then see how they differ. And then if you can make, you could also make like in the column D. Yeah, you can in column D you could make, for example, like a total duty. In column D.
There's no difference in these two numbers.
Yeah, because it's a very there's no much different. Yeah, and then it's also like yeah, that one. You have to write it. equal. Yeah. Nah. And then
tarik this.
try. I don't know if you can do so. No, you cannot do so. No.
I can't.
No.
Manually.
Manually. So you can better use symmetry for this. You know symmetry. You know icon.
Yeah.
In icon there is a process calculator, and you can do copy paste. It is not as advanced as Excel, but it is more advanced than this spreadsheet.
Yeah, but all
Nothing changed, yeah. So yeah, we can also see the number because I could not see the number. Okay, now 4 point. Okay, so in this case, looking at this number, yeah, roughly it's kilojoule per hour. Can you change it to kilowatt, for example, the duty? No, yeah.
No.
The unit, yeah. Okay, so okay, no, okay. So in this case, you can see changing the feed location from stage 2 until stage 6 doesn't change the duty whatsoever. So that means, yeah, you can put your stage location at whatever you would like to put it, basically.
Alright.
In other cases, you might find that when you change the stage location, the reboiler duty and then condenser duty, they will change drastically. But hence, if you go back to the profile, because the profile, because we know we know that the feed composition is about 40%, and then about 10% of the 40 for that DME and water, and then 10%, 20% of the unrated methanol. So if you go to that profile, you can see that this, I mean, this is roughly in that these stages are, I think, more or less the same like in the profile. Hey, what happened?
I can't I can't make it open the spreadsheet the spreadsheet thing.
Okay, fine. So until now, is there any questions on this column? So we are not going into the details, but if you have any detailed questions, please go ahead. But then if there's no questions, I can just let you do the second column.
Right.
Can you double? Okay, yeah. Just do the second column now.
Okay. Opening the textbook now.
I will say it to you. So you can just drag your column, and then I'll mention I'll tell you the number of stages and the fit location.
The same column.
The same icon. What is that? You have to change the fit location first. Back to yeah, stage. Can
Stage 3, okay?
fine. I mean, you have seen it, yeah. Stage 2, 3, 4, 5, 6. They're all okay. I mean, the 6 is that you need to have a higher pressure, but then if you put it to
Right.
now, second tower is 26 stages, including reboiler and condenser. So 26 stages, and then the fifth stage is at stage 14.
14.
14.
Stage 14. You have to.
Sorry, this is
This
11.
11.
Yeah. Eh?
I don't know. I don't know which one is which. Yeah, you can. I mean, you can just push this window.
they actually have a they actually have a valve in
Yeah, they have a pressure reducer.
Okay. Reduce the pressure first, and then you will see.
How do I disconnect?
You've done this several times already. Find until you can find this. Yeah, move the mouse until you can find the tick.
Right.
Yeah. Yeah, move the tower to the right. Wait, why is it so difficult?
Oh, okay.
Ah,
Alright. Valve 11 to 12.
and then stream 12, it's 7.4 bar.
So, how many?
That one I don't know. You go to worksheets.
3.1.
I don't know. Is that? I don't know. Go to worksheet and then you can confirm it.
Worksheet.
And double click on and then go to worksheet. There. You can see it. You know, you're coming with 10.5, and then your stream number 12 is 7.4.
Yeah, it's similar.
So in this valve, you specify the delta P.
6, stream 12, investigation.
14. Yeah. 14.
Right.
And then if you see the column, right? The top pressure is 7.3 bar, and then we are condensing fully the methanol. I will just let you figure that out. Yeah, I mean.
Okay.
reflux.
Total reflux.
Sorry.
Yeah, is it total, partial, or full?
This is a total.
Why?
13.
Because everything is liquid.
Yeah, exactly, because everything is condensed to liquid. So it's total reflux. Bottom stream is number 14. Overhead is 13.
Okay.
Next. Next. Condenser pressure is top column is 7.3. It's too much.
Alright. Bottom is I don't know.
Bottom is
7.6.
7.6.
Yeah, that's the pressure in the stream 14. 7.6, yes. Next. This one you can just skip. Yeah, next. Done.
Right.
Now, yeah. Now this one. What do you want to control and what do you want to see? Because last time we would you can open again the previous column, yeah, to have a comparison, for example.
Right, we were controlling the reflux ratio and distillate rate.
Yeah.
We specified DME recovery at purity.
You don't specify it because it's not active, but at least you want to see the products, purity and recovery, and also the duties of the reboiler and condenser. Right? At least these 6. I normally see these 6 parameters.
Let's do that. This can delete. How do we delete?
And you can add, yeah,
one component fraction.
yeah, for the purity, yeah. And which component fraction, because you want to, in this case, you want to recycle the methanol, right? So you want to have like a pure methanol back into the reactor, because we don't want to have water into the reactor. It will take up some space, right? So we need to have the methanol as pure as possible.
Methanol is set up condenser. This is mole fraction. Quick. I need my calculator for this.
Very good. But this is for purity, you don't need to calculate. But okay, if you because this is it's going to be stream number 13, yeah. Stream number 13, yeah. You can start with stream number 13 exactly. Very good.
Yes.
63.6 divided by 66.3. How much is that?
6.
Yeah, roughly. And then that is the methanol. Very good. Very good. Close, and then the add spec. Recovery of methanol.
Recovery of methanol is 98.9.
How do you get that?
Fraction at stream 13 divided by fraction at methanol at stream 13 divided to the methanol flow rate at stream 12.
Excellent.
Stream
13, yeah. Laptop. Yeah, and then add the duties. Yeah.
Or 6 is reboiler, I think. Is it?
Sorry, say again.
6 is reboiler.
You can move this window to the so that you can see the column. The 206 is reboiler, 207 condenser. Yeah.
Right. Okay.
So now in this case you make active reflux ratio and distillate rate, but you don't specify any value yet, so it cannot run, right? It's all still empty, this reflux ratio and distillate rate. So you could put the reflux ratio and distillate rate, the specified values of these two, and then let the column runs, or you can just untick these two and then take the purity of methanol and recovery, and that could also be the case, yeah. And entering the tower below stage pressure. So yeah, it's you can check it later, but okay, in terms of mass balance, not no problem. But okay.
1.6, isn't this a bit too high?
Well, it's not that high. I mean, you have to see, to get how to read that is that to get the purity of methanol as specified, and then to get to get the purity of methanol as specified and the recovery of methanol as specified as well, you need to have that reflux ratio.
All right. Okay.
So that's how to read that. So you could now you have this 1.67 1.697, yeah. You could put that in the specified value of the reflux ratio and also the distillate rate, and then you can then play around with that and see how much is then the methanol purity and the recovery that you can get. It is also see
pretty much the same.
Now you can play around. Yeah, if you put it at 1.4, see what happens. See, if you reduce the reflux ratio, you get a lower purity.
Yeah.
Why is that?
Because less overhead are being recycled into the tower.
Yeah, because you have exactly. So you have. It's more like you are washing your dirty clothes. So the more water you put, the more you wash, the cleaner the clothes will be, right? So if we reduce the reflux ratio, means we are reducing the washing stream, so to say, into the column. So yeah, then we are left with dirtier or less purity of methanol.
Alright. Okay.
So if you increase the reflux ratio, and then the purity will increase, but also you can also see that your reboiler duty will increase as well. See?
Yeah.
So yeah,
I think this is an okay number.
it's okay number. Okay, fine. Well, that's an okay number. And then you can see in the profile, see that you can kill some of the stages as well, right?
Yeah, from 15 to 20-ish, I think.
Yeah.
Or 19. 15 to 19.
15 to 19. So 15 to 19 is about 4 stages, and then now you are how many stages? 26, yeah.
22. Should we cut it?
Yeah.
Try?
Fine. Make it 22. Yeah. Now you have to check. Stage 22. Sorry, your feed stage. Where's the thing? Click on pressure. Click on pressure. That monitor. Press. So you are coming at stage 14, right? So stage 14 is close to 750. 750. The feed is coming at 740. Alright, can you still remember your feed is coming at 740? Yeah, so I mean in terms of pressure, it will not flow. Yeah, so that means you need to increase the pressure of your feed stream.
Right.
So you need to increase it to 750. Uh-huh.
770?
No, it's also fine. Yeah, I mean. See.
So now we are at.
You okay? I mean, you are entering at 750, and then you are coming at 770. But okay. Yeah, the correct way is then to have it at the same pressure, but at least you can have it has to be at least the same pressure, otherwise yeah, I mean it's mathematically it's going to be fine in terms of mass balance, but then for it to flow, it's you need to have at least a higher pressure a little bit.
Oh yeah, or else there would be like backflow or something.
Yeah, exactly. It will not flow to the column, but then it will flow from the column.
Okay. Now, I've cut down the column now, but
yeah, you can still see some useless stages, eh?
Yeah.
Yeah, and then you can cut even more.
Okay.
So this is what we call, what you're doing now is basically like more like a designing the column again from the previous proposed design, so to say.
That's quite good.
While you're doing so, yeah, you could also do the same like what we did in the spreadsheet. You can then make like a table of the number of stages, and then the duty of the reboilers, and then also the purities of the methanol and recovery. See, you can now your purity is now 94%. So it's lower. It used to be like 96%.
Yeah.
So in this case, with the shorter stages, I mean the less amount of stages, to get the same amount of purity, you will need to have a higher reflux ratio, which means you will need to have a higher reboiler duty, basically.
Right, 2.2.
2.2. So the best way, yeah, I mean the best way is then let's make this like a more, because we cannot do case study, so let's make it more manual in the spreadsheet. So you make a table of number of stages, reflux ratio, the reboiler duty. The goal is then to maintain the purity and recovery so that you have a apple to apple comparison. Right, so this is okay. So that means you can just copy the reflux ratio and then the duties, and then vary the number of stages, for example, and then you can see.
Sorry, but the reflux ratio as well.
Yeah. Because doing process simulation, you have to click somewhere. Okay. Doing process simulation is also trying to understand what the process is and how it behaves. You could also use the actual Excel sheet, yeah, for this. Yeah, not necessarily that you should use the spreadsheet here. Maybe you can put also next to it the feed location, because your feed location is still at stage number 10. It's number 10.
Was it number 10? I think it was number 12. It was at 14.
Oh, it was at 14, but then when you cut it, it just moves along with it. But okay, so that means we have to make sure that yeah.
Okay.
Add another column. Add another column, maybe that one.
Column. I'm trying to use a new spreadsheet.
Oh, okay. Fine. Here you can put like number of stages, and then feed location, and then reflux ratio, and then reboiler duty.
Right.
Click home.
The number of stages, flux ratio, and
Reboiler. Because condenser, in this case, condenser is very cheap. It's cooling water, so and add as well in between B and C, it add that feed stages. Yeah. Nah. You can put everything is now 14, and then for the feed stages. Now it's 19. 19, right? The 6 stages is 19. Yeah kan? Number of stages is 19. Aisyah.
19.
Ya kan? 19 kan?
19.
Ya kan? Coba try to see the was it 19 or 18? Yeah, okay, 18, 18, yeah, 18. And now you can change it to 20. Change it to 14. Yeah.
One point 748.
You can make this window smaller, right?
How do I? Oh. Can I only open this one?
Yeah, yeah.
I can't. Ready to. One point 708.
We'll stop until stage 24, yeah, and then you can extend it further, but then for the sake of this exercise, we'll just stop at stage 24.
Alright.
Feed location, yeah.
Point 7. Right.
Now, what do you see?
There's a. Of course, there will be increase in both reboiling and condensability. There are less demand for energy, and decrease in the reflux ratio.
Yeah, and then you can see it's 22 to 24. It's 1.7, 1.7, and then that 26. It will probably close to 1.7 as well. So that means increasing the stages further than 20 stages, 22 stages. So you will not give any. There is no benefit anything whatsoever if you increase the stage number of stages from 22 above. Now you have to check which one is then which. You want to make the number of stages as x-axis and then the rest as the y-axis. That is the correct way.
Let's see.
And then here you can change it, check it, double click on the
On this one here.
Yeah, okay. See, you cannot trust Excel, eh? Because sometimes it does some crazy stuff. And then the Y is then the reflux ratio. You cannot do so, Aisha. You have to select one Y.
Y. Only one Y.
For one set of data, one X, one Y. Hey, this is Excel lessons. Click, yeah, and then right click on that chart and then you select data.
Select. Hold on. Select data.
And then you go edit, you edit, and then you can then name it whatever you like. For example, you want to say reflux ratio, right? Okay, and then your x-axis should be the number of stages. Delete all of them.
Number of stages.
Yeah.
And this
is reflux ratio. And then series number 3, you change it to reboiler duty, for example. It's also number of stages and then the reboiler duty. Yeah. And that's it. And then remove that.
condenser.
Up to you. Yeah, you can put condenser. Good. So now you have a very strange scale, but in any case, you can make the graph much more beautiful later. You can just tick and untick which one you would like to see. Say, what do you want to see now first?
Condenser duty.
Condenser duty. Fine.
There's everything. Right. So we have this.
Yeah, so you have a reduction in the condenser duty. Yeah. And then you can see so at the beginning from that stage number 18, so you have a steep increase if you add the stages, but then if you add stages more above 22, 24, they are about the same. Going to be plateau.
Alright.
So that means you can see, I think you can see if you change it to the reboiler or the reflux ratio, you could see the same pattern.
But Doctor, what is the best practice? As in like cost, right? I mean, is it viable to add more stages? Because this one is we are maintaining the purity at 96%, right?
Yeah.
All of this one, right?
Yeah.
So, what is the best practice? Is it going for lower cost of energy, as in reboiler duty and condenser, or we add number of stages?
Very good. So what do you think, Shafiq? If I give you the assignment to design me the most economical column, I put the word the most means the most economic means to what does it mean to you? Most economic.
Less cost, high impact.
Less cost, high impact. Okay. I don't know what you mean by high impact, but then let's start with the less cost. How do we define cost?
CapEx.
OPEX.
CapEx and OPEX, exactly. So CapEx, what is CapEx here in the column?
The number of stages.
The number of stages, yeah, a number of stages, and then also the size of the reboilers and condenser. So these are the CapEx. And then what are then the OPEX?
The duty.
The duties, especially the duties of the reboiler, because the duty of the condenser is cheap. Yeah, it's cooling water. It's nothing compared to the reboiler duty, because reboiler duty in this case, because you are having this at about 160, 170 degrees C, so we need to have like 7-8 bar of steam. So it is steam. So we need to pay to make that steam. So that is then the OPEX. So in our process optimization course, we have learned to account for these two. So that means we need to know how much money, because you have the numbers of reboiler duty, right? So for example, you have take this 40,000 something. It's how much is this? There's so many zeros I cannot see. So this is close to half a million, or it's 4 million something. It's about 4 million kilojoule per hour, right? So it's a very strange unit, but anyhow, so that means to get that kilojoule per hour of energy, assuming 100% of because if we say that this is coming from the steam, and this steam is going to be condensed in this reboiler to provide the heat, right? So, and then if you don't know, then you have to the bottom temperature of the column is about 170 degrees C. Yeah, it's 167 degrees C. You can check in the HYSYS. It's about that number, and then that means if you allow for 20 degrees C temperature difference, so that means 170 plus 22, it's about 190. So that means we need to have a steam condensing at 190 degrees C. So you could see that this is, I don't remember what the pressure is, but then it's about maybe above, maybe, I don't know, maybe 10 to 15 bar, I don't know. And then we have the numbers, this half a million of kilojoule per hour, and then you can change it to kilojoule per second, right?
Yeah.
And then typically steam condensing at 2000 kilojoule per kilogram. So that means kilojoule per second divided by kilojoule per kilogram, we get the kilogram per second of steam. And then this kilogram per second of steam is the steam produced in the reboiler, in the boiler system. So this steam is coming from is made from by heating up fuel, for example, right? So methane gas, for example, or like any other fuel. So if we assume like I don't know, maybe 70 to 80% of fuel consumption efficiency, so that kilogram per second divided by that efficiency, so we need to have sorry, I did it wrong. So in kilojoule per hour, we change it to, yeah, I did it right. So from kilojoule per hour of energy, we can divide it by the kilojoule per kilogram of steam. So we get the kilogram per second of steam, and then this kilogram per second of steam, if we have it, because you could do it directly from the natural gas, for example, using the efficiency. So we have the duty kilojoule per hour, and then divided by the efficiency, and then for example, if we are to use natural gas, so natural gas energy is about, I think it's about 54 megajoule per kilogram. I don't remember. But then you can then calculate how much is then the natural gas consumption. Yeah, can you follow?
Yeah.
If not, then you can say so, yeah. Because I need you to be able to follow. And then we get the OPEX calculations, and then the next is then we need to know the CAPEX calculation. So if we say, for the sake of the simplicity, so we're not going to account for the size of reboilers and condenser, so we're going to account for the size of the column only. So that means we need to know how much is then the price if we add 1 or 2, or for as a function of number of stages. So in this case, we can go to I think they have here number one source is, and you can go to, or like online source, like in this 2-ton book, they have the cap cost. You can Google cap cost Excel file, and then you can then specify the column, the sizes, and then it will give us the rough estimation of the cost for different, for example, in this case, different number of stages. So we can use that as the capex, also in the reboilers if you want to. The other option is then you can go, in this case, I think they have this in Aspen, they have this Aspen Economic Analyzer, so you can run it, and then you can have the comparison. So you have now the comparison as the functions of the number of stages. You have for each of these stages, we get the capex, and then we get the opex. And then the opex is the cost is about, I mean, the cost in opex is in time, but then the cost is capex is there's no time. Yeah, it's just like dollars or ringgits. But then the cost in opex is dollar or ringgits divided by time. So we need to then change this capex into like a timely cost. So typically we will have like we will do like a what they call it, annuity something. So we need to, for example, if you let this column run for 20 years, and then the capex say 10 million ringgits, yeah. So it's 10 million ringgits, and then you need to run this at for 20 million, for 20 million for 20 years, and you can just do like a rough depreciation. So 10 million divided by 20 years, so that's roughly that you have to pay the column yearly. Yeah, it's not accurate, but it's just to get a rough indication. So you get ringgit per year, and then for the capex, and then for the opex, you can also calculate into ringgit per year. So ringgit per year capex plus ringgit per year opex, that is then the total cost per year. So you get the total cost per year, and then you know the number of stages, and then the corresponding number of stages, and then the corresponding reboiler duty, and then you can then see which one is then the cheapest one. Can you follow? I think yeah.
So means we need to I mean in this case
Yeah, in this
we
case.
have a number of stages, so means we need to calculate every single combination, right?
Yeah. That is then the correct way. That is the correct way. The incorrect way. Yeah, the incorrect way. Because adding one or two stages is not really I mean in this case for gut feeling, yeah, for me practically, if we don't have resources, or we don't have time to do so, and then we can see from here, because typically the reboiler duty governs, or the reflux ratio governs. So in this case I would stop at stage 22 or 23, for example. So that's my number of stages, which leads to the lowest reboiler duty. Because this reflux ratio, it varies from country to country, from region to region. Let me tell you why. Because you know, yeah, you know that by varying the reflux ratio, we have a corresponding capex, means corresponding number of stages, and then the corresponding opex, means the corresponding reboiler duty, right? So these two, you have it in the head. So now, say for example, you are living in Europe, and in Europe, energy is not cheap, yeah. While in the US, energy is cheaper, historically. Okay, so in the Europe, because energy cost goes to the reboiler duty, right? The higher the reboiler duty, the higher the energy cost, and then the more we have to pay. So since the cost of energy is expensive in Europe, people will then tend to design tall columns.
Right.
Yeah, because when tall columns just capex, so they just spend once, and then they will let it run for 20, 30 years. But then for this reboilerity, because it's expensive, they have to pay this expensive amount of money every year. So they don't want that. So they have a tendency in Europe to install tall columns. But in the US, on the other hand, because well, they have big cars, petrol is cheap, and everything is cheap. So MACD is also cheap. So so they have a cheap energy. So they tend to design very short columns. Right, so well, because energy is cheap, so we just design it very short, and then they don't really care about the reboilerity. It's cheap anyway. So so you would see, yeah, if you I think you need to go after this COVID. So you travel to Europe, travel to the US, you can see and then prove me whether I'm wrong or right, and then you will see hopefully big fat columns in the US, and then the tall and skinny columns in the Europe.
Just like the paper.
Exactly. Yeah. So that's I mean that's a tendency. Yeah. It's not like it's not like the correct I mean it's not fully 100% correct, but that's the tendency that I would normally see. That the correct way to do this, as we have just discussed, take into account all the costs, because especially nowadays in this internet age, and also the capability of the software that they have built-in capex. Yeah, you can see in this Aspen HYSYS, they have built-in capex. So you make a flow sheet, and then you can just click on it. I think you can click on it. Yeah, you can show me, if you show me that HYSYS. Close this. Yeah. close it again, and then you can see that capital. You can see that capital in that there are three tabs in above your flow sheet.
All right.
That one. Exactly. You activate that. Yeah. Yeah. So this is one click button. It is very dangerous. But for the sake of this example, I will just let you click on it.
How dangerous?
Dangerous. It's dangerous. They will then jeopardize your career as an engineer. Means it's I mean the cost estimation from this one click button is because they're going to be using like a typical or default numbers to design, because to be able to calculate the capex, as you understand from your PDP class or plan design class, you will need to size it, and then how they size it, it's on using like default values. So these default values, it may be right in some cases, but it may be wrong in other cases. And then to be able to make it like if you go to, for example, you go to investor, you say, so in this case, yeah, total capital cost is 7 million. And then if you go to your investor saying, I need to have 7 million so then I can design this DME plant, that's not going to happen. Yeah, so this absolute number is not the correct number. So it is just an approximation. It may be right, it may be not right. So you need to see the how they calculate the cost behind this. But this is a good way if you have different designs. For example, yeah. How much is that? So can you memorize this number? Capital cost 7 million, and then operating cost is 3 million a year. Yeah.
Okay.
And then now go back to the flow sheet, and then you can just change, for example, the column, which column you want to change. Just change that one, make it like a taller by 4 stages, or shorter, make it in the 20 stages, for example. Stage number 14. Yeah, and then close, and then run that thing again. Yeah. Take some time, eh? Do you see any difference?
Just by 500, by 5,000.
Yeah. So that strongly depends on what is the cost factor behind how they calculate this. But it's just like you are changing like 4 stages. Yeah, what do you expect? You will not get any significant difference. It's just like a 4 stages, and then that's it. So at least it gives you a feeling on how to use this. So if you have what you could do in this, what I've learned so far, we cannot use the absolute number, but we can use the relative number. So it means you have to have like at least 2 designs to be compared with. So you can say that one design is cheaper by, I don't know, 10 or 5%, for example, compared to the other design. How much? And then that means you have to do a more rigorous capex calculations or cost calculations to be able to tell the absolute number. But relatively, you can use this as a tool to compare with. Okay. So so we have done our 1-hour session. So I think it's good now. At least now you know how to use this spreadsheet, and then you know then this capex roughly. I think next week we will discuss on how to navigate, because you can see in the column, next to this column, next to this each of these 2 columns, there is a small item. Can you see to the left of the column? There's a small kind of column.
There's a yeah.
Oh yeah.
That one is the internal design. So we will do this next week, and then just to see how we design it, how we design the column internally, and then you will see then the impact and so on and so forth. And then maybe the next 2 weeks we will then go to the to how to make a recycle of the system.
All right.
Okay. So in the meantime, yeah, just play around with this, and then you could also try the other cases of this Turton. If you find any problem or anything to discuss, just let me know. Yeah, because this is then your session, so you need to ask me any questions. Yeah, I cannot tell you everything I know because I don't know what you know, and I don't know what you don't know. So you have to tell me what you don't know and what you want to know.
All right.
Okay. So thank you very much, and I'll see you next week. Yeah.
All right.
Thank you. Bye bye. Save this. Yeah. Don't
Thank
forget.
you, Doctor.